this presentation on learning how to mimic using model explanations to guide deep learning training. I'm Matthew Watson, and this was joint work with Bashar Hasan and Noura Moubayed from the Department of Computer Science in Durham University. And this work was sponsored by the European Regional Development Fund and Evergreen Life. Any gold standard machine learning model should be able to achieve high performance while learning causal relationships. But while measuring the performance of a model is easy, measuring its causal relationships is much more difficult. A couple of years ago, the MIMIC-CXR-EGD dataset was released, which is a collection of 1,083 chest X-ray images with associated eye gaze data from a clinical radiologist. And the authors of this dataset found that there's very little overlap between explanations from a model via techniques such as GradCam or SHAP and the expert's eye gaze data. And our own studies found that the KI divergence is extremely high at about 14, and the normalised Scanpath Saliency is very low at about minus 0.8. And what we wanted to do was study how we can improve this level of agreement. This figure here is just 3 random samples from the data set. And on the left, we have the expert's eye gaze data. In the middle, we have GradCam explanations from a baseline UNet classification model. And on the right, we have GradCam explanations from a UNet classification model which actually uses the eye gaze data during training. But as you can see, neither of these models have almost any overlap with the. So what we do is we have this idea of deep explanation ensembles. And we train an ensemble of submodels, each of which uses different type of parameters. And then during training, we use model explanations to improve the features learned. And by encouraging the ensemble submodels to produce similar explanations, the contribution of noisy features is reduced. And we encourage this by introducing a discriminator during training, which is trained on explanations from each submodel. And as you can see from this loss function in the bottom here, the aim of the discriminator is to classify which submodel a given explanation came from, while the submodels are trying to fool the discriminator. And this technique has extremely good results. So here we have a different 3 samples from the data set. And again, on the left, we have the eye gaze data, followed by a baseline UNet model, followed by the UNet model, which uses eye gaze data during training. And then on the right, we have GradCam explanations from our deep explanation ensembles. And as you can see, just by looking at these results, there's much more overlap between explanations from our model and explanations from the other models. And this is backed up by the statistics. So these 2 box plots at the top of this slide here show that the normalised Scanpath Saliency goes up with our deep explanation ensembles, and the KI divergence goes down with our deep explanation ensembles. So what we've shown is that deep explanation ensembles do improve the agreement between model explanations and expert eye gaze data. Also, while explanation consistency and model classification performance is also improved, and that unlike current state-of-the-art techniques, we don't require expensive eye gaze data to be used during training.